Good evening, good afternoon, sorry. And we are going to do questions on the radioactivity. The question of radioactivity, we do whatever the question we left in the paper, these questions, and we do questions, and whatever we do, we learn something from radioactivity. Okay, question 10, the last page, question 10. Okay, question 10, 10A. Question 10A. The paper you have the radioactive question paper. Question 10A. Okay. Figure 10.1 and 10.2 shows the activity of the radioactive decay of the two radioactive X and Y. This question came up from before SPM. But they gave this question radioactive X and Y. But actually, I saw this question, they give the actual name of the radioactive substance. Actual name of the radioactive substance. Okay, they give the actual name. Okay, what is the first question? The first question. Okay, the first question is a radioisotope. What is meant by radioisotope? What is meant by radioisotope? Okay, radioisotope means isotope which are radioactive. Isotope which are radioactive and can undergo nuclear decay with emission of alpha, beta, and gamma. Okay, radioisotope means isotopes which are radioactive and can undergo nuclear decay with emission of alpha, beta, and gamma. Okay, the next question, question A2, using figure 10.1 and 10.2, state the common characteristic for the radioactive decay of substance X and substance Y, relating the common characteristic of the radioactive decay of the two radioactive substance X, Y, and Y, deduce a relevant physics concept. Okay, the first question, X, this is X. So this number is 800. 800 and time, the time given in minute. And given minute and Y. This is Y. And 1600 number, 1600 meter the activity, and the time is minute 10 minute. Okay, minute. Okay, the first question, the first one is first question, the first part, for X and Y, the activity or rate of decay decreases exponentially with time. For X and Y, the activity decreases exponentially with time. Okay, exponentially with time. This is exponent graph, the activity for X and Y. So all the radioactive substances, okay, whether emit alpha, beta, gamma, all the radioactive substances, they decay or decreases this manner, or decay or reduce by this manner, or this we call it this one exponentially decay. So X and Y, regardless any radioactive substance, all also decrease this way. Okay, the second point for X, the rate, the activity for X, the activity is halved after every interval of 4 minutes. Okay, for example, after this, this one 400. 800 become 400, become half of it. The time taken 4 minutes. 400 become 200. Take time taken is 8 minutes. So the 4 minute gaps, 4 minute interval. So the radioactive substance 4 minute interval. Okay, so you must understand this one. So for X, the activity after every time interval of 4 minutes. 4 minutes. Okay. For Y, next point, third point. For Y, the rate, the activity. For Y, the activity is half after every time interval of 10 minutes. Every time interval of 10 minutes. Okay, that is called half-life of Y. So Y, the rate of decay is half, okay, or the activity. For Y, the activity is half after every interval time of 10 minutes. 10 minutes. For example, this one 800. 1600 become 800, the time is taken on 10 minutes. And 800 become 400, takes 20 minutes. So the interval time is 10 minutes. The 10 minutes difference. Okay, so every time of interval. So X every 4 minutes become half. Every 4 minutes become half. Y every 10 minutes become half. Every 10 minutes become half. Okay, and the physics concept. Physics concept. Okay, the physics concept is the activity is half after every equal time interval. Okay, the activity half after every equal time interval. This is called as half-life of a radioactive substance. This is called physics concept. 2 marks. Okay, the first 3 points and the last 2 points. Physics concept 2 points. There are 2 marks. Okay, because you are mentioning the 2 points there. Physics concept. Again, I repeat physics concept. The activity is halved after every equal time interval. Every equal time interval. For X, 4 minutes, 4 minutes, 4 minutes become half. For Y, 10 minutes, 10 minutes, 10 minutes become half. And this is called as half-life of a radioactive substance. Radioactive substance. Half-life radioactive substance. We call it half-life. Half-life. This one is a decay rate or decay activity rate. It become half-life. We call half-life. Okay. Next question. We're going to go these questions. Cobalt. Okay. I taught this question in Saturday group, but I didn't teach Monday group and Tuesday group. So that's why I repeat again. For Saturday group also you block. Saturday group also you can listen to me once again. Okay, Cobalt 60. Question number 1. Question B1. Cobalt 60 disintegrates into nickel by beta emission. Write an equation to represent the disintegration of cobalt 60. So cobalt 60 and 27 disintegrate. That means they are break into or decay into nickel. We don't have to write the nuclear number and proton number. Don't write beginning. At the beginning, don't write first. Okay, but beta emission. But beta emission you must write. Beta is represented by electron 0, -1 plus energy Energy we don't write also lemma, but you write this one. Okay, cobalt 6027. They say beta and beta emission. So beta represented by electron 0, -1. That's a fix. So we must, if the beta emit beta, you must write in the equation electron 0, -1. Then you balance it out. You balance this out. This one plus this one must be same as this one. So before and after the same. I told you this one. I told you radiative decay. So the total nuclear number before and after will be the same. So this one 0 is 60. So nuclear number 60 and this one -1 is 28. 28 plus negative 1, 27. This is called, this is how you balance it. You balance it. Okay, so, okay, next question. Next question. Thorium-228 disintegrate into radon by emission, alpha emission, Write an equation to represent the disintegration of thorium-228. So thorium-228 and 90 disintegrate decay, become disintegrate alpha emission, become radon. So don't write the nuclear number and proton number. You write it at the end. Okay, at the end. But you must write this one first. Alpha must helium-42. Alpha represent the helium-42. You must write this one first. And energy. And energy. Okay. So thorium-228 and 90. Thorium-228, 90. Alpha. With alpha represent helium-42 and energy. Okay. So this one is, you must plus this one. So total nuclear number before and after will be same. So this one will be this one. So will be 224. 224 plus 228. Okay. And 90 plus 1, 88. 88 plus 2 is 90. So that's it. Let's call it, we call it thorium decay, become or disintegrate, become radon by alpha emission. Okay, this question number 3 is a very interesting question. Question 3 is a very, very interesting question. Question 3. Okay, question 3, please read question 3. Please go through the question. Okay, this is the half-life question. Phosphorus 32 decays to non-radioactive sulfur 32 with half-life of 15 days. So phosphorus becomes sulfur. A sample initially contains total of 4.0 times 10 power 22 atoms of radioisotope phosphorus 32. Find the number of phosphorus 32 atoms and the number of sulfur 32 atoms present in the sample after 60 days. So this question is a very, very interesting question. Okay, for example, phosphorus becomes sulfur. For example, 10,000 phosphorus become 5,000 sulfur and 5,000 phosphorus remain, haven't decayed yet. Okay, 10,000 phosphorus become 5,000 sulfur. Sulfur is a decay and we call it lost decay. Maybe decay. It's two things. So sulfur, phosphorus becomes sulfur and the remaining another 5,000 phosphorus. Then again 5,000 phosphorus become 2,500 sulfur, another 2,500 remain as a phosphorus. Okay, I'll explain this one to you. Okay, a long table cut into two pieces. Okay, cut into two pieces. Half of the table become chair. Another half remain in the table. From long table, another half remain in the table. Another half become chair. Okay. From the half table, you cut another half. So another half of the table is remain table. Another half become chair. So something like this. Something like sulfur, phosphorus becomes sulfur and phosphorus. Okay, so this question, I want to do this question. We have to understand. Okay, this one is please. Okay, 4 times 4.0 times 10 power 22 phosphorus become half. 2.0 times 10 power 22 phosphorus in 15 days. Divide by 2 divide by 2. 4.0 divided by 2. So remain after 15 days, remaining is 2 times 10 power 22. Another half become what? Another half 2.0 times 10 power 22 becomes sulfur. Become another half sulfur. Another half is sulfur. So after 15 days, the remainder is 2.0 and 10 power 22 phosphorus. Okay, remainder. Okay, and another half become sulfur, another become half sulfur. So after another 15 days, so 1.0 times 10 power 22 phosphorus. So another half become sulfur. This one, another 15 days later. 15 days later, 0.5 times 10 power 22 phosphorus. Another 15 days later, so 0.25 times 10 power 22 phosphorus. So 60 days. They ask 60 after 60 days. What is the for sulfur and phosphorus? Okay, 15 days, 15 days, 15 days, 15 days. After 60 days, after 60 days, after 60 days, the phosphorus remainder is 0.25 times 10 power 22, or become 0.25 times 10 power 22 phosphorus, the remaining phosphorus. After 60 days, 15, 15, 15, 15. After 60 days, the remaining phosphorus is 0.25 times 22. What is sulfur? What is sulfur? How much sulfur it turned to after 60 days? How much sulfur it turned to? How much phosphorus turned into sulfur? This question asks you. How much change to sulfur? How much sulfur? How many sulfur change to sulfur? So how many phosphorus change to sulfur? After 60 days. So the beginning before 60 days, 4.0 times 22 phosphorus. After 60 days phosphorus, 0.25 times 22 phosphorus remain. The rest of it is belong to sulfur. Rest of it change to sulfur. So the one is 4.0 times 10 power 22 minus 0.25 times 10 power 22 is sulfur. So equals to sulfur for 3.7 point, I think so. 3.75 times 10 power 22 sulfur. This is answer. This answer. So after 60 days, the phosphorus, remaining phosphorus 0.25 times 10 power 22 or equals to 2.5 times 21 phosphorus. Same. So 2.5 times 10 power 21 phosphorus or 0.25 times 10 power 22 phosphorus remaining after 60 days. After 60 days, how many phosphorus change into sulfur? So before 60 days, the phosphorus is 4.0 times 10 power 22. After 60 days, the phosphorus remain is 0.25 10 power 22 phosphorus. So the rest of it is changed into sulfur. So this one minus this one. Okay, minus 4.0 times 10 power 22, 0.25 times 10. Okay, so this one is 3.75 times 10 power 22 sulfur. 3.75 times 10 power 22 sulfur. Okay. Next question. Question 9. Okay. Question number C is about pipe leakage. Pipe leakage. I taught last week. Pipe leakage using beta. Using beta. Must be liquid, must be mixed with water, short half-life, so that it's not dangerous after repairing the pipe and releasing back to the consumer. It's not dangerous. So it's a very short half-life. So all these things, information. Question C. Okay, I told you, sir. But we do one question. And question 9. Question 9. Question B. Question B we do. Question B. We do question B. Okay? Question B we do. Okay? This question is about oil, what do you call it? Volume control system. Okay? A motor oil producing factory wants to develop a volume control system to ensure the volume of a motor oil in a metal tin within a specific range. The tins of the motor oil are transported to a conveyor belt as shown in figure 9.1. If the volume oil is more than the specific range of the volume, the tin will be removed automatically. So I will explain this one to you, how the system works. How the system works. Okay, I'll explain to you this one, how the system works. Okay. 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 Okay, the oil producing company is something like this. Okay, the conveyor system or conveyor belt. Have you seen? For example, in Tesco, if you go to Tesco, you want to pay to the what do you call it? Pay the money to the what do you call sales girl or something like that. Okay, pay the money and you take the things from the trolley and put it in the conveyor belt. Then automatically it goes like this. It go like this. Automatically move like this. So then they can you can pay the money to the okay. And that's how the system conveyor system. All that conveyor system, conveyor belt, some airport, luggage bag system, conveyor belt. Have you seen airport? Okay. So this one is the, what do you call it? The bottle. So the bottle or tin. This question is tin. So oil. So tin is not transparent tin. It's not transparent tin. So the first thing, the tin come like this. The tin come like this. Okay, the tin come like this. Okay, the oil filling station. Okay, for example, 1000 ml, 1000 milliliter. So 1000 cc. Okay, 1000 ml. Okay, they fill oil, and the tin will move automatically to the through the conveyor system to the next station. Next station, inspection station. Inspection station. They will have radioactive substance or radioactive rays. Especially here, it's a metal tin. If a cardboard or bottle of, for example, carton or something like that, so cereal, milk, juice, and all these things must use beta emission. I told you last week, beta emission. But this question, because metal tin, so it's better to use gamma. So they have sent the gamma radiation here, and through here there's a detector. They detect it. So it's maximum, minimum. Okay. So then this called detection system or inspection system. Okay. Then this bottle or the tin will move to the next station. Next station, accept reject station. Accept reject station. There will be, if rejected, there'll be robotic arm come and take this out from the system, or remove automatically. Reject this. Because the other tin is coming. Okay, so all tins, all empty tin waiting in the list. So inspection, filling, inspection, reject, reject. Okay, if accepted, this tin will go to packing station and they pack. Okay, can you understand? Okay, this is a conveyor system or conveyor belt Okay, this system. Okay, repeat again. This oil filling station, fill oil. Suppose with 1000 ml. Suppose you fill 1000 ml. Okay. This one go to the next station. Next station, inspection station with the radioactive rays. So gamma, they send gamma to through the tin and detector. The receive the sensor or detector is part detector. So if the oil is right volume, right volume, it will be accepted. If the next station, if the oil is less or more, less and more, less than 1000 ml or more than 1000 ml, it will be rejected automatically. Rejected automatically because another tin must come. Another team must come. Oil filling station, inspection station, and accept reject station. So another thing is so the tin continue coming. So this rejected tin must be removed automatically. Otherwise, if this rejected tin is in this place, next tin cannot come. Next tin cannot come. So next tin, not the next tin or fill up tin must come out. Come this oil in the what do you call it in the conveyor belt. This must be rejected. Or this must be accepted. Accepted is packing packing go. So this is a conveyor belt. So nothing done human. Nothing done by human. It's done automatically. Okay. So I will explain to you this one. Okay. Okay, explain to you. Okay, the first question. Explain the suitability of the type of radioactive substance alpha emitter, beta emitter, and gamma emitter used in the volume control system. So the alpha emitter and beta emitter is not suitable. Not suitable because they cannot penetrate tin. Because they cannot penetrate tin. This question number one answer. So bulk alpha emitter and beta emitter. Alpha emitter and beta emitter is not applicable or is not suitable in this system because this system is metal tin. It's a metal tin. Usually beta emitter use volume control system. As I told you last week, usually volume control system they use beta. Okay, beta because bottle, like cardboard, like something like cotta drink. In all these things, they are both beta. Usually beta. But this question, special question. This question is metal. So metal must be alpha, gamma emitter. So the gamma, alpha emitter, beta emitter is not suitable because cannot penetrate metal tin. Alpha and beta emitter is not suitable because they cannot penetrate metal tin. Gamma emitter is suitable. Gamma emitter is suitable because it can penetrate the metal tin. It can penetrate the metal tin with some absorption. Okay. And the second question: draw a diagram to show how equipment can be assembled. How the equipment can be assembled. Okay, how the equipment can be assembled. Okay, this is tin here, and this is a source 1. Source 1, this is source 2. Source 1 and source 2, there is gamma emitter source. Gamma emitting source, gamma emitter. Okay, and this is what do you call it? Sensor 1. Sensor 1 and sensor 2. Sensor 1 and sensor 2. Okay, sensor 1 and sensor 2. Okay, and the right liquid should be in between. This is maximum. This is maximum. This minimum. This is maximum. This minimum. Maximum minimum point. So the right liquid should be or right oil filled up should be in between maximum minimum point. So this will be like that. It's a like sorry. the right liquid volume, the right liquid volume, correct volume liquid, correct volume of liquid is between maximum and minimum, between maximum and minimum, this one. Okay, and we call it okay. Next question. Next question. I'll give the answer and explain to you later. I'll give the answer. Next question. Question number 3. Explain how the system works. Okay, system works. Okay, first of all, question number 3. Sensor 1 indicates the maximum level and sensor 2 indicates the minimal level. Sensor 1 indicates maximum level and sensor 2 indicates minimal level. This is a maximum level and this minimal level. If the oil volume is correct, the sensor 1 will receive a high input and sensor 2 will receive low input. Okay, this one I for you. This is sensor 1, this sensor 2. Okay, correct volume. Okay, sensor 1 is high. Sensor 1 is high and sensor 2 is low. Low input, high receive low. Please listen to me. Okay, this source 1 sent gamma sent this gamma. So gamma sent through the empty space. So because of that empty space not part absorption. So because of sensor 1 receive high input, high reception from gamma, high volume or high reception, high radiative what do you call it, source, high radiative we call it high radiative what do you call it, ray received by sensor 1 high because less absorption. But sensor 2 low because oil this area sensor 2 is minimum area, so oil filtered area. So gamma is sent here, gamma is sent here also. So this gamma absorbed by the oil. So oil absorb the gamma radiation. So sensor 2 receive low input. This is the correct volume. So sensor 1 receive high input. Sensor 2 receive low input. So accept. Okay. If the oil is okay. Next question. When sensor 2 detects a high input, it means the oil volume is below the minimal level. Sensor 2 detects high input. Okay, this one. Okay, this one. Okay, and okay, the oil is less than this one. Oil is lesser than stipulated, or the 1000 ml oil will fill up. So oil is less than minimal level. So the sensor 2 receive high input. What will be the sensor 1 reception? Also high, because this empty area, this also empty area. This oil is below minimal level. So that one is a less than minimal level. Less than minimal level, high. Okay, reject, accept. Reject. Is still rejected because below the minimal level. Okay, you label it 1000 ml. but you give it, for example, 800 ml. So customer won't be happy. Customer sure complain because less than minimum level. Okay, then that's called second point. Second point, when the sensor, second point, when sensor 2 detects high input, it means that oil volume is below the minimum level. Below the minimum level. Okay. Next, third point, when the sensor 1 detects low input, the oil volume is above the minimum level. Sensor 1 detects low input. When sensor 1 detects low input, that means the oil volume is above the maximum level. Above the maximum. For example, okay, this one. It's a minimum level, after maximum level, it's minimum level. So the oil is above. So this oil is here. So the source 1 send the gamma emitter, source 1 gamma emitter, the gamma pass through oil volume area, so sensor 1 receive low input because absorbed the oil, and some of the gamma is absorbed with oil. Here also low because oil area, so it must be more than maximum level. High input and high input. Sorry, low input. Okay, low input. Low input and low input. Just low input and low input. It's more than maximum level. So, what do you call it? The tin is accepted or rejected? The tin is rejected. The tin is rejected. The tin is rejected. Okay, because maximum level, more than maximum level means source 1 send gamma and the gamma absorb the oil. So sensor 1 receive low input, absorb some of the gamma absorbed by the oil. So sensor 1 receive low. Sensor 2 of course sensor 2 also receive low because it's absorbed by the oil. So this is what accept, reject. Okay, so accepted, the tin will be go to packing. The reject, the tin will be rejected by the automatic robotic arm reject from the conveyor system. The conveyor system reject. Okay, reject all the robotic arm, take like this, the tin take like this and send out from the conveyor system, because conveyor system the other tin must come. Okay, this one must be some of the this question can be logic gate question also. This must be sensor 1 high input, logic 1, logic 0. This logic 1 and 1. This 0 and 0. So what we are using, sensor 1. Logic gate question. It's not logic gate question. Okay, this and this one is a robotic arm. Robotic arm X. X must be output from logic gate. This is logic gate. So this logic gate, from logic gate, output must X. This not related to this question, but I still teach you extra in case the question combined. Logic gate X. So X must be output 1 in order to get robotic arm. So robotic arm is activated when? Robotic arm activated when? During accept situation or reject situation. The robotic arm supposed to be activated reject situation. Reject only. So robotic arm reject means take this off. So reject in two situations. Either less than minimum level, oil is less than minimum level, or more than maximum level. Less than minimum level, customer complain, because if you label is 1000 but you get 800 only, so customer sure complain okay. But maximum level, the boss complain because you are supposed to give oil 1000 ml, but you give 1200. So, boss rugi lah. Okay, boss rugi. Loss. So both situation, the minimum level, maximum level, rejected. So the situation, robotic arm works when the situation X may be 1 or logic gate may be what do you call it, logic gate must give the output 1 lah, X1 lah, and robotic arm works. So this situation, this logic gate, what is the logic gate? AND gate, OR gate is not suitable because 1 also must logic 1, 0 also must logic 1, logic 1. So this is special gate lah. This gate out of 5 gates we learn AND gate, an AND gate, OR gate, NOR gate, and NOT gate. But this gate is a exclusive OR gate or exclusive NOR gate. Okay, exclusive OR gate, something like this. This one like this. This is another color. So this one exclusive OR gate, exclusive NOR gate. This gate is not syllabus, not syllabus. But I'll teach this one because I want to tell you this question may come out. This kind of question may combine together with the logic gate question. So this is a logic gate exclusive or exclusive NOR, either one. Okay, this one rejected. So robotic arm works activate when rejected situation. When the tin is rejected. So for the tin rejected, robotic arm to activate to reject the tin from the conveyor system, conveyor X by 1. X by 1. X must be logic 1. So X can logic 1, logic gate here might be NOR gate, or sorry, this one exclusive OR gate or exclusive NOR gate, either one of the gate. Okay, this one I will teach you this one, and okay, I would like to teach you one question. Okay, we do questions. Question 2. The question 2, especially question C. The question I told you that the question is some question is nobody so far not many people, not many students done this question. Question C. Question C. Radioactive counter is set up as a background as a count 20 counts per minute per recorded. The radioactive sample is placed then less than a centimeter from the detector, and the counter is records 820 counts per minute. The half-life of the radioactive sample is 4 hours. What is the count rate recorded by the 4 hours later? Okay, this one is this question. This question is a radioactive counter. There's a counter, something like a detector, something like a detector. And the detector, they put radiative sample, the sample. And it shows, the counter shows 820. 820, the reading. Because before they put a sample, counter reads 20 counts per minute. 20 counts per minute. 20 count minutes. This is a background. This one background is something like that. We thought Byras supposed to show the counter supposed to show 0 because no radiative sample yet. No radiative sample yet put before the counter. Supposed to show 0, but the counter shows 20. The counter shows 20. That is the background. Background is, I told you, the radiation 3 ways absorb. The counter absorb radiation 3 ways. One cosmic radiation. One from Earth. Another one from surrounding. surrounding. So 3 sources is background count. Background count. So 3 sources is absorbed. So then we put a sample. They put a sample. And now the sample is the radio counter shows 820. 820. But actually, what is the activity of the sample? 800 only. Actually, the activity of the sample is 800 only. 20 is from the background. Automatically, something like, for example, emitter shows 0. Suppose 0 shows 0. So a counter suppose shows 0, but the counter shows 20. Okay? For example, your watch is 8 o'clock, but you set 20 minutes fast, so 8:20 shows 20. So 20 minutes fast, so 8:20. But suppose the watch shows 8 o'clock, but 8:20, because 20 minutes fast you put it. So the 20 counts per minute is from background, without the sample. So background automatically is from cosmic, from radiation, from cosmic radiation, from the radiation from the earth, radiation from the from the surrounding factories, radiation. So it's going to be 800. Actually, actual count per minute, CPM 800 only. Okay, after 4 hours, so suppose we want 400 CPM. But they asking the question, what is the half-life radiative sample is 4 hours. What is the count rate recorded by the counter after 4 hours? It shows the counter. Counter shows always 20 extra. So this one must be 420 CPM. You suppose right, not CPM, no, count per minute, full name. 420 CPM. Because 20 is from extra from background. So something like your watch, 20 minutes fast. So it shows 8:20. But suppose suppose time is 8 o'clock, 4 o'clock. Suppose time 4 o'clock, but your time shows 4:20 because 20 minutes fast. 20 minutes fast, you put it 4:20. Suppose time is 4 o'clock, but 4:20. So something like that. The 20 count is from background. Okay, now another 4 hours, 8 hours. This is question number 1. Question number 1. Question number 2. Another 4 hours later, 200. But after 8 hours, after 4 hours, after 8 hours is 200. But what is the recorded? What is the recording by the counter? Recording by the counter is 20 extra. So is for 220 CPM. This question is 220 because it's for example watch 20 minutes fast. So by that suppose to 2 o'clock by 220. Okay, because the 20 is counts per minute is come from background. Okay, in this question I will finish this question. But the next week, next class, next lesson, we are going to do a revision. I will post the revision paper to you. I will post the revision papers to you. You must do it 1 week. Today or tomorrow I will post it. And you must do the questions, objective questions, maybe first objective question, structure question, I don't know. I will post the paper, you do the question, then we do next class, we do questions, based on the question revision. Okay, that's all, thank you.